Alrighty, we are looking at triangles again today, and specifically what we're looking at is a midsegment. So our objective is that we want to be able to apply the triangle midsegment theorem to triangles to be able to find missing information within that triangle. So what is a triangle midsegment? Well, a triangle midsegment is basically going to be a segment that extends from the midpoints of the sides of the triangle to another midpoint. So when you have a triangle, it's going to kind of look something like this right here. If I find my midpoints right here, so here's all my midpoints, that right there is what's a midsegment. And so in a triangle, you're going to see if I connect all of my midsegments together there, you're going to end up getting 3 different midsegments within that triangle. And so kind of looks like a Triforce for any Zelda fans out there. But that's what a midsegment is. Now, the triangle midsegment theorem says this right here is that if the midsegment is parallel to one side of the triangle, then its length is going to be exactly half of the side to which it's parallel. So the midsegment here, if it's parallel to that side, then that means that this midsegment's half the size of that parallel side. So that's what it's going to look like. So a couple examples here. And so this is kind of the first thing that I have here. And I wrote this formula out. There's not really necessarily a formula per se, but this is essentially what it's saying is that your midsegment, the value of that is just going to be 1/2 of whatever the parallel side is. So if I look at this here, I've got what is the length of BD? So I'm trying to find that length here if AE is 12 inches. So that's 12 inches. And so what I need to do is I could either use this little formula that I've set up there, or I can just apply that theorem. And so that theorem basically says that this midsegment here is going to be half the length of that parallel side that I have going on there. So if I use that formula here, the midsegment, we'll just call that X because I don't know what it is going to be equal to 1/2 the parallel side. Well, the parallel side here is just going to be 12. And so that's what I'd have there. And so when I go through, half of 12 just comes out to be 6. So I would say that BD, that the measure of that is just going to be 6 inches. And so that's how I use that midsegment theorem. All right. Next, we've got this one here. And so this is saying what's the length of AE if BD is 15 meters? And so again, we know this value right here, but we don't know that value here. And so you could always use that formula that I kind of created right there. You can use that. Or the other thing that you can do is you can just say that, hey, this midsegment is going to be half the size of that. Or if I have that, that basically just means that I've got essentially a midsegment here and a midsegment here. It's basically taking that midsegment and putting it into 2 different things there. So it's doubling your midsegment. So if I go through here, midsegment is going to be 15, 1/2 my parallel side. We'll just write down AE since that's what I'm dealing with there. And so now I have to get rid of that 1/2. 2 ways I could do it is I could just divide by 1/2. That would be one way. So I could do like 15 divided by 1/2 is going to be equal to AE. I can put that into a calculator to figure out my answer. Or when you have a fraction, if you multiply by the reciprocal, so the flip of that fraction, if I multiply each side by that, it gets rid of the fractions. And so that right there is just 15 times 2, or 2/1. So when I do that, I would get that this comes out to be 30. And so that would be 30 meters. And that's what my value for AE is. And that is the midsegment theorem in practice.